So in this video, we're going to talk about volumes. We're going to talk about, this is going to be a series of videos, so just stay tuned. We're going to talk about volumes, slicing, which is what we're going to touch on right now. So slicing is the idea that we're going to find the volume of some sort of, object given the fact that we're going to slice it into circles. So maybe if I'm given a function like, x is equal to y squared. Right, the idea is that I could slice this into a disk, right? So I could actually rotate around several axes, right? So let's say my rotation is about the x-axis. Now I could rotate around the x-axis or the y-axis. And the formula that you should remember for this in terms of slicing using the disk method is the integral from a to b of pi r squared dx. Now this is if we're walking along the x-axis. Now notice, if I'm walking along the x-axis, well, what is my r? My r is from the actual axis to the function itself, right? And we know the function here is actually, well, in this case, we could say, and I'm not gonna, this is just some function f of x. In this case, I initially said this was x is equal to y squared, which is, well, which it is, right? Which it is, right? So, but the main point I want you to get away from this is that the volume of any one of these circles that we could form is equal to integral from a to b of pi times, well, what's my r? It's from the center to the actual function itself. So in this case, we're going to talk about this function in terms of x. So this will be f of x squared dx, right? So that's the whole idea. Now you could also look at these things from from the y perspective. So if I could get my line here straight, and maybe we have some sort of, and these are just random functions. This is just pure for illustration purposes. So maybe I have some random function here and I want to slice it, and this may be called g of y. So let's call the function g of y. And maybe I want to slice it around, and maybe I want to, use the disk method around the y-axis. Well, you could see that if I kind of, and these are just symbols that I kind of draw in my head to kind of show that I'm actually kind of cutting this thing up into some sort of disk. I could actually rotate around the y-axis, and the volume for this is given by the integral of c to d of pi. Well, we just said this is pi r squared, but our function is always from the axis itself to the function, right? So this is my r, right? Same, just in this case, this is my r also. I'm just integrating around different axes. So I could integrate with respect to x, or I could integrate with respect to y. So this will be pi r squared. Well, what's my r? It's g of y. So this is g of y squared dy. Right. So those are my integration formulas that I should remember for volumes of slicing using the disk method. Now, I'm going to quickly introduce the washer method. Typically, the washer method and the disk method are literally the same thing. Now, the washer method, the formula that I want you to remember is this. With respect to x, the volume is going to be equal from a to b of pi big R squared minus pi small r squared dx. Now, what does this mean? All we're doing here is saying that in order for us to find a volume, between certain curves, well, I'm going to take pi and multiply it by the radius, or in other words, the function, the upper function minus the lower function. So we're going to go through some examples to kind of get this idea concrete. So this is with respect to x. Now, if we're talking about with respect to y, then the volume I'm just going to call it a to b again. From a to b is given by pi big R squared minus pi small r squared dy. Notice the difference between these two. The axis that you're integrating with should always match what you're taking your integral with. So I'm integrating with respect to y, I should have a dy. I'm integrating with respect to x, I should have a dx. So with that being said, let's look at an example. So what if we wanted to find a region bounded by the curve, y is equal to x squared plus 1, and then y is equal to negative x plus 3. What if we wanted to find a volume of this solid here? Well, again, typically with these problems, graphing is not required. However, it's helpful, right? It's helpful. So we know that graph of y is equal to x squared plus 1 is just shifted 1 units up, and it's a parabola. Again, these are just sketches. I know the graph of y is equal to negative x plus 3 is a line with a negative slope shifted 3 units up. So I could say this is somewhere along here, kind of teetering around here, right? And now we could see a beautiful area under the curve, between the curves. So this is what we're trying to find. Now, if we're integrating this with respect to x, well, if I'm going from this point, let's see. So if I'm going from this point to this point, well, if I'm walking, what's my upper function? It's this y is equal to negative x plus 3. What's my lower function? It's this y is equal to x squared plus 1. So my volume is going to be the integral from a to b of pi big R squared minus pi small r squared dx, right? Because we're integrating with respect to x, we're walking the x-axis. Now the big question here is, what are my limits of integration? Well, to get these, you simply set the functions equal to each other. Now the functions have to be equal to each other in a sense where you both have to have y is equal to something before you could set them equal to each other, right? Or vice versa, you both have to have x is equal to something before you set them equal to each other. So in other words, what's my point? My point is I could not have set these functions equal to each other if I somehow had, if I move this x over here and add a plus x, I had an x plus y is equal to 3. I could not set x plus y is equal to 3 to x squared plus 1. So both your variables have to be equal to some function of x, some values of x, before you could set those equal to. So the only thing was to just set these equal to each other and see what are my limits of integration. All right. So if I set, let's do it on the side. If I set x squared plus 1 is equal to negative x plus 3, well, x squared plus x minus x squared plus x plus 1 minus 3 is equal to 0. All I did was move all my, sorry, the contrast. All I did was just move all my terms over to the left side of the equation. So this simplifies to x squared plus x minus 2, and that is equal to 0. Well, if I factor, this becomes x plus 2, x minus 1, and that is equal to 0. So therefore, you definitely could see that my limits of integration is actually where x is equal to negative 2 and where x is equal to 1. Now that I found my limits of integration, I could just simply go ahead and plug into the formula. So my volume is going to be given by the integral of negative 2 to 1. It's always your lower number to the higher number. So it's from negative 2 to 1. All right. Now we could do this integration two ways. I'm going to do it by factoring out my pi. So this is, since both of them have pi, in general, I'm going to factor out my pi. So this is pi. Well, what's my r? This is the bigger r, right? So this is top function. So walking along the x-axis, my top function is negative x plus 3. So this is negative x plus 3 squared minus, well, what's my lower function? That has to be x squared plus 1 squared. And don't forget, we got to attach our dx since we're integrating with respect to x. Now this now becomes a simple integration. So this is from -2 to 1 of and since pi is a constant, I'm going to factor this out. So I'm going to factor out my pi. So this becomes -x plus 3 squared minus x squared plus 1 squared dx. Yes. So continue with my integral. I could expand this thing. So this is the integral from -1 to 2 of -x plus 3, and this is a squared, times -x plus 3 minus x squared plus 1 times x squared plus 1 dx. I'm going to put a bracket since I'm taking integration of all this. All right. So now I could just go ahead. So this becomes the integral from -2 to 1. If I factor if I distribute, I get a let's see, -x squared. So that's a positive x squared minus, well, -3x minus 3x is just -6x plus 9. So if I factor that, those are the numbers that I would get. Minus, if I not factor, but if I distribute these, this will become x to the 4th plus 2x squared plus 1 dx. Again, bracket, I'm taking the integral of all of this. All right, so this now literally becomes a simple integration problem where I could combine like terms. Right, so I could combine like terms. So the integral, and usually you could write, well, let's forget this. So I'm gonna still have my pi times the integral from -2 to 1. All right, so now this becomes x squared minus 6x plus 9. Well, if I distribute my negative to all this stuff here, this becomes -x to the 4th minus 2x squared minus 1 dx. Now, because I'm a little bit tricky about my stuff, I like my highest power to be in the front. So if I simplify this a little bit, my pi stays out on the front, and this becomes the integral from -2 to 1 of -x to the 4th minus x squared minus 6x plus 8 dx. And all I'm doing here is just simplifying. So -1 plus 9, that gives me a plus 8. I still have my -6. I still have my -4 to the x, and I still have my well, -2x squared plus 1x squared. That's just a -x squared. So all I did was just simplify there. Now I simply have my integral in terms of a polynomial. So this now becomes a simple integration. So if I take my integral of this, I'm going to keep my pi outside. All right, so the integral of -x to the 4th is just -x to the 5th over 5 minus 1/3 x to the cube, right, minus 3x squared plus 8x. And this is going to be all evaluated from -2 to 1. Now again, how did I get my 3x squared? Well, if I take the integral of x, that is just x squared over 2. 2 divided by 3, 6 divided by 2 is 3. So that's how I get my 3x squared. Now this becomes just a matter of plugging in. So if I plug in, I'm gonna again keep my pi outside. I'm gonna put a huge bracket. All right, so top function first. So you could agree that this is -1 to the 5th over 5 minus 1/3 times 1 cube minus 3 times 1 squared plus 8 times 1. All right, and this is going to be all minus, and I should have never put a bracket here. So okay, so let's put a huge bracket around here just to show that my pi has been distributed. So this now becomes -2 to the 5th over 5. Run out of space here. Minus 1/3 -2 cubed minus 3 times negative 2 squared plus 8 times negative 2. And I'm running out of space here, guys, but this should be 8 times negative 2. And there's a parentheses here, all signifying that my pi is being distributed. Now, what will I get? I will get pi. Well, negative 1 to the fifth is just negative 1/5. That is just negative 1/3. Again, nothing changes because I have a 1. 1 squared is just 1, so negative 3 times negative 1 is negative 3 plus 8. All right, so these are my numbers. I'm going to subtract that, put a big parentheses because my pi has been distributed again to negative. I still have a negative outside, and so that will become positive. So this is 32, right? So negative 2 to the fifth is 32. And now it will become a positive because negative 2 to the fifth is negative 32 times this negative here. So this is a positive 32 over 5 minus, well, what is negative 2 cubed? Well, again, I'm still going to get a negative number. So this will become positive since I have a negative. So this is positive 8 over 3. And hopefully you could see that negative 2 cubed is negative 8 times the negative is a positive 8 over 3 minus, well, negative 2 squared, negative 2 cubed is negative 8 again. Well, I'm looking at it wrong. Negative 2 squared is positive 4. All right, so negative 2 squared is positive 4, but we're going to have a negative since we have a negative outside. Well, negative 3 times 4 is just 12, plus 8 times negative 2, which is that this is not a plus, since 8 times negative 2 will give me a negative 16. Now, if that's the case, well, let's see. Let's do a little bit of math here. So this is pi times, well, negative 1/5 minus, negative 1/5 minus, negative 1/5 minus 50 plus that. So this should be pi times, if I simplify this, and this should be negative. So if I simplify this, should be pi times negative 33 over 5 plus 30. All right, so there's a negative 3 over 5 plus 30. If I multiply by 5 on both sides, this now becomes pi times negative 33 plus 150 divided by 5. And if I distribute negative 33 plus 150, that's just 117 pi over 5. So that would be my answer. Now, there's going to be a second and third part of this video, so just keep on watching. In the next video, we're going to talk about the volumes around rotating around the y-axis and how we would integrate those along with some practice problems also.